All right, today we're talking about geometric sequences. So these are slightly different than our arithmetic sequences we've gone through before. Instead of them going up or down, kind of adding a number over and over again to get to the next number in our sequence, to be geometric, it's going to look like we're either multiplying or dividing by a value. So what I mean by that is, let's say you have a list like 3, 6, 12, 24, etc. Okay, this would be an example of a geometric sequence. So we could say we are multiplying by 2 every time we go up in value. Now, sometimes a geometric sequence will look like division. So we will see something that look like division. So for instance, if you saw a similar list backwards, 24, 12, 6, 3, etc. This would be 3 halves. Here it looks like we're dividing by 2. Technically, we always think of this in terms of multiplying. And so you're really multiplying by 1/2. That's the same as dividing by 2. So you're multiplying by 1/2. And that's where you kind of see when you multiply by 1/2 why we end up with 3 halves for this next term. So this ratio that we're multiplying by, or this number we're multiplying by to get to the next term, whether it's 2 or 1/2 or whatever our value is called the common ratio. Okay, so to be considered a geometric sequence, all terms have to have a common ratio, which we use lowercase r. So instead of common difference for arithmetic, common ratio. Okay, so to calculate the common ratio, you can always find it by dividing any term in your list by the previous term. So for instance, the one let's say that was 1/2 up here, right? Put a couple of these back up. If I take any of these terms, say 6, and divide it by the previous one, so 6 divided by 12. When you reduce that fraction, dividing top and bottom by 6, we get 1/2, which is what we were multiplying by, right, to get to the next term. You can even confirm something is geometric by checking that that ratio is always true in your list. Any term divided by the previous term should always give you 1/2 for that particular geometric sequence. Okay, so we'd say r is equal to any term, except for the first, because there's no term before it, but any term divided by the previous term. Okay, so it can be found by dividing any term by the previous term. Now, there is a formula to find a term far out in our geometric sequence. It's obviously a different formula than when it's arithmetic. And this formula is as follows. A sub n just means the value of the term at position n, or the nth term, is equal to the first term in our sequence times the common ratio. And usually it's a good idea here to put parentheses around our common ratio. I'll go ahead and add those in for good measure, because sometimes the common ratio can be negative, in which case you have to have parentheses. To the n minus 1, where n is the number in our sequence we're trying to find. So if you're trying to find the 10th term, you'd plug in 10 for n. So n is your position number in the sequence. So we're going to leave those parentheses there. Okay, so here's a list of some sequences. Let's see if we can tell the difference between geometric or arithmetic. So determine if it's arithmetic, geometric, or neither. If it's arithmetic, find the common difference d. If geometric, find our new common ratio r. So I always like to, my personal preference, I like to look at a sequence and think about maybe it has to do with adding and subtracting. So in this case, we're definitely going down. We went down 2, down 2, down 2, down 2. It looks like we're just subtracting 2 over and over and over again. That's a sign that this is arithmetic. So think of arithmetic like you learned in elementary, right? Adding and subtracting. It'll look like we're adding or subtracting the same number over and over and over. And the common difference here is that value, -2. That's what they're adding over and over again to continue to decrease in that list. Okay, number 2, if I'm thinking of terms of subtraction, I don't know, we went really far down. But wait, then we went way up, right? We went from a negative to a positive. So I don't think we're adding or subtracting the same number. I think we can kind of rule out arithmetic for this problem. So maybe it's geometric. Well, let's see. Let's check and see if we can find a common ratio. And you can actually use any numbers in here. So I'm gonna come over to the easier ones. Let's take any term and divide it by the previous term. So 3 divided by -6. If I divide both by 3, I get -1/2 is my fraction. Now let's check. Now remember, if this is geometric, I should be able to do this again and get the same value back. So let's try this again. I'm just going to pick 12. 12 over -24. So we're dividing by the previous term. If I divide each by 12, we get 1 over -2. So notice that we got the same ratio both times. That's called our common ratio. And that is a sign that this is geometric. And in fact, r, what we're multiplying by every time to go to the right, is -1/2. So as you can kind of tell, if you have a negative number you're multiplying by over and over again, your list kind of alternates. A positive, then a negative, then a positive, then a negative. That's right. When you multiply a negative times a negative, you get back a positive, and a positive times a negative is negative. Okay, let's take a look at number 3. So again, I always like to look in terms of addition. Looks like we're going up 2, but that would be +3. So it's already not the same number over and over again. So we can rule out arithmetic. I mean, I guess, well, wait, that'd be +4 and +5. I mean, I see a pattern. Maybe it's geometric and I just can't see it. Let's try our ratio way, right? So let's say I did 6 over 3. 6 over 3. Well, that would reduce to 2 over 1, right? Dividing each by 3. Let's see if we get the same ratio back somewhere else. I'm going to do 15 and 10. I'm just picking some numbers here. Now remember, if it's geometric, we should, when it reduces, give me the same fraction. But if I divide each by 5, I get 3 over 2. And these are not the same ratio. So it does not have a common ratio, which means it's not geometric either. So for our last one, this is actually neither. Neither, neither, potato, potato. But that's it. It is a pattern, right? +2, +3, +4, +5. In fact, this is actually called a quadratic pattern, but we're not going to go over those this year. So for now, we're just going to say it's not geometric and it's not arithmetic. It's neither. Okay, so let's utilize this formula and try to find some terms kind of far out in a geometric sequence. So here I have a sequence, and it looks like we're multiplying by 2 over and over again. And in fact, here's our sequence written down here nicely in this table. So I'm going to kind of notate that. It's kind of like times 2, times 2, times 2. And whatever we're multiplying by is my common ratio. So if it's one that's kind of obvious here, like times 2 over and over again, we'll go ahead and just say, yeah, hey, my common ratio is +2. I also know my first term, right? And up here we're going to write these as our position numbers. So that's the first number in my list, the second, the third, the fourth, and the fifth. Right? They give me the first 5 numbers. It says to find the next 2 terms. Well, let's just follow our pattern, right? Times 2 is 160 for the 6th term. Times 2 again would be 320 for the 7th term. Now it says then find the 10th term. So could I just do this a few more times? 8, 9, 10 and get my answer? Yep, absolutely. And I mean, even if we did that, what would the 8th be? The 8th would be 640. I mean, I don't have a place really here for the 9th, but the 9th would be 1280. And then the 10th would be 2560. I could be wrong here. We're going to figure it out. But we're going to go ahead and also utilize our formula, right? Because if it had asked me for like the 25th term, I don't want to have to calculate every one of those by hand, and maybe I lose count if I don't write them all down. So let's use our formula here. So to find this, to find the 10th term, we're going to plug in 10 here for n. This is just notation on the left. Equals the first term. Well, our first term was 5. Times, remember we're going to put this common ratio in parentheses. So let's put those parentheses back there, which is 2 to the n minus 1 power. So up here to the 10 minus 1 power. So now we go to our calculator. Okay, so here's the Desmos scientific calculator. Let's try this out. We're going to put 5 times parentheses 2, and then you can either hit this like a to the b, this will get me up in the exponent, or shift 6 on most keyboards. And we can write 10 minus 1 And I notice it took me out of the exponents. Maybe let's put some parentheses here. 10 minus 1 power, or you could just put to the 9th power, of course. And check it out. There's our answer, the 10th term. We confirmed it by just calculating them out, and we confirmed it with our formula. The correct answer is 2,560. All right, so here's another problem, very similar. Write the explicit formula. So this time it actually wants me to write the formula like this, but we're even going to leave n as n so that we could use it for any term. And then we'll find the 8th term. Okay, so let's figure out what they are multiplying by this time. Kind of looking like 3, but it's changing signs. So I'm going to say -3 times -3. Now again, if it's not as obvious, right, what they're multiplying by, I can take any of these numbers, especially if I know it's geometric, I only have to do it once, like if they tell me it's geometric, and divide it by the previous term, I can see that we will get -3 over 1, or -3. Okay, so that is my r value. All right, so we know r, that's good. We'll need that for our formula up there. We also will need our first term, which is 4. I'll go ahead and I'll put our position numbers up here for the first 5 terms they've given us. Oops, 4 or 5. Okay, and then let's write our generic formula. So I'm going to utilize some space here for it. So in the generic formula, we just leave n as n, so we can plug in and find any number we want. But we need to plug in the first term, which for our list here is 4, times parentheses, my common ratio, right, which is -3. And this one specifically, you need parentheses around your common ratio, to the n minus 1 power. Okay, so this is the explicit formula. It's the formula I can use to find any term in my list. Let's use it to find the 8th term. Now, again, could I do 6, 7, 8, right? Can we just calculate out a few more terms? Absolutely. Maybe we'll do that in a second to confirm it. But let's try our formula first. So if I'm finding the 10th term, a sub 10 equals 4 times -3 to the 10 minus 1 power, or 9th power. So let's try in the calculator. Okay, here's our Desmos calculator. 4 times parentheses, -3, shift 6, or again this button will get you up into your exponent. Parentheses, so it keeps this in the exponent. 10 minus 1. Or you could just write 9 as your exponent there. And it tells me my 10th term in this pattern ends up being -78,732. Okay, so I've gone ahead and written that here. Let's check, continuing our pattern, right? If we continue the pattern here, we were at 324, and our pattern is just to keep multiplying by -3. So let's say times -3. This would be the 6th term. So go ahead and write that in, -972. Let's multiply that by 3. Okay, there's 972 times -3 is positive 2,916. Okay, we've got that written in. Okay, and since we get it all the way out to 10, I tried to save us a little bit of time here. I went ahead and just continued multiplying by 3. So we knew this was the 7th term times 3. This would be the 8th term times -3, the 9th term, and times -3, the 10th term. And that's exactly what we calculated back when we used our formula. So saving ourselves a little bit of time in writing, that formula comes in nice, especially when we need to find values that are really far out in my list. Okay, our last example here, write the explicit formula if the 3rd term, so remember that this means the value of the term at position 3. So I actually know the 3rd term here is 64. And r, which is for the common ratio, means what we're multiplying by to go to the right, is 2. So they're kind of multiplying by 2, I guess, right, to continue to the right. Find the 10th term. Okay, well, we could just keep going in this order, right? I mean, if this is the 4th term, it would be 64 times 2. That'd be 128. The 5th term times 2, that would be 256. The 6th term times 2 would be 512. And we could just keep doing this, right? I've only got room for 8 here, but we could try to fill in 9 and 10. maybe get up there. This is 1,024, 2,048, 4,096, I believe. And if we did it again, 8,192, I think. Now, to use this formula that we have at the top, remember, I need the first term, and unfortunately, they didn't give me the first term. I could, however, use some deduction that if I'm multiplying by 2 to go to the right, we could just divide by 2 to go to the left. So if I kind of cut these numbers in half, this would be 32 and this would be 16. And now I actually know my first term, and we have enough information to use that formula. So let's confirm with our formula that we should get 8,192. So the value of the 10th term equals, so in the formula here, the first term, which is 16, times our common ratio, which they told us is 2, to the 10 minus 1 power. So let's go to Desmos. And there we are. Yep, 16 times 2 raised to the 10 minus 1 power is indeed 8,192. Now, it did ask me to find the 10th term, which is 8,192. We've got that. It did also actually ask for the explicit formula, right? I should read my directions more carefully. So let's go ahead and write the generic formula that just leaves n as n. So it's the first term, which we did have to find in order at least to come up with this formula, times 2 to the n minus 1. So there is our explicit formula and the value of our 10th term, which we also found by just kind of continuing the pattern. Obviously, formulas are much better to go with if we're finding a value that's really, really far out in our pattern, and it would take us a really long time to calculate. Okay, that's it. We'll do some more examples in class and answer any questions.